So now here we are going to see that how to apply the logarithmic rule, but here we are going to study when do we apply the case 3, it means the long division technique. So understand, if you have been given a question in which the degree of the numerator, so degree of the numerator means that the highest power of the function given in the numerator is 2, whereas the highest power of the terms which is given in the denominator is 1. So if the degree of the numerator is bigger than the degree of denominator, then always apply the long division technique. And I guess that you guys are familiar with the long division technique. If not, then watch my video which is already uploaded in my channel. Now, first write the dividend which is written inside, that means all the numerators. Write the divisor outside, and now whatever you will get, it will be quotient. So the first thing is always divide the first term of the dividend with the divisor. It means the first term of the dividend should be divided by the first term of divisor. Here you will get x, write it at the place of the quotient. Now one by one multiply this quotient with the divisor. So x times x will gives you x square. X times 1 will gives you plus x. So write the x square under the x square and the x term under the x terms. Now in the division we always subtract the terms with each other, so change the sign. It is plus, so it becomes minus, so plus x square minus x square cancel. It is minus 3x and you will get minus x, so minus 3x minus x will gives you minus 4x. Bring the 2 down. Now again repeat the steps. Divide the dividend's first term with the divisor's first term, that means minus 4x divided by x will gives you negative 4. Write it in the quotient, and now this negative 4 will be multiplied with the divisor. So you will get negative 4x, and negative 4 times 1 will gives you negative 4. Then we change the sign, negative changes into positive, positive changes into negative, and sort out the problem. Plus 2 plus 4 will gives you plus 6. Once it is done, we have to integrate the function because now it is written in the simpler form. So first we always, in the integration, we first always write the quotient plus remainder divided by divisor. So quotient is x minus 4. Then here remainder is plus 6. And remainder will be divided by the divisor, that is x plus 1 and dx. Now integrate all the terms one by one. X, the antiderivative of x will be x square over 2 minus antiderivative of 4 will be 4x. And here you have up over down, the derivative of x is 1, which is written on the top. So you will write ln of denominator x plus 1. But 6 is extra, so you write the 6 before ln of x plus 1 and then plus c. How we integrate the numerator and denominator if its derivative is on the top? See, in the first and the second part we have explained it very clearly. One more question where we have to apply the long division technique. Again, the degree of numerator is 3, which is bigger than the degree of denominator, that is 1. So you apply the long division technique, x cube minus 3x square plus 5 divided with x minus 3. Now x times x will gives you, divide x cube by x, you will get x square. You will write on the top, multiply one by one with the divisor, you will get x square times x, x cube, minus 3 times x square will gives you 3x square. Now you will change the sign, and minus 3x square plus 3x square also cancelled, and you will get 5. Now look here, in the remainder 5 left, and the degree of 5, there is no x term, it means the x has a 0 degree. So the degree of the remainder, if it is less than the degree of divisor, you have to stop doing the division process. Now write the integration sign. Write the first of all the quotient, that is x squared, plus remainder, that is 5, divided by divisor, that is your 3, x minus 3. Take the entire derivative, so x squared, by using the power rule you will get x cube over 3. Here up over down, the denominator has one power. You will use the rule u prime over u. So 5 is extra, so you will write the 5 as it is, and logarithm of x minus 3 plus c.